So today we're going to go over Chapter A, Section 1, Similar Polygons. Now, the keyword here is similar because they're not congruent, they're just similar. So they're going to have similarities, but they're not going to be equal to each other. We have corresponding parts of similar polygons. We have the first one, which is corresponding angles are congruent, and corresponding sides are proportional. That is the keyword, guys. Only the angles are congruent and the sides are proportional. So what does that mean? That means that A and M are congruent, B and N are congruent, C and O are congruent, and D and P are congruent. Now the similar symbol is a little squig. That's terrible squiggly. It's a little squiggly. And we have, let's run an example with this. They're telling us the angles are congruent on the right side, and they're telling us the segments are proportional. So again, that is why we did the warm-up on proportions. I want you guys to understand how that would work. So if, for example, we know that angles A and M are congruent, we know angle B and angle N are congruent, we know angle C and angle O are congruent, and we know angle D and angle P are congruent. We also know that the scale factor is going to be similar or proportional because this is what we're working with. So if the original did tell you that it's, let's say, 6, 8, 10, and 8, just because, the model from the quadrilateral ABCD to MNOP is they're telling us it's similar with the squiggly right here. We can say that the model has been scaled down. So it's just a smaller version. But the key part right here is the ratio will be the same. So knowing that, I'm going to make up a ratio, guys. I'm going to say this is 3. I'm just dividing all of these by 2 because I'm making up this example as we go. So the scale factor is you're going to grab, let's say, this 6 and this 3. So you're going to go, well, it's 6 over 3 for that segment because that is a segment that is similar. It's going to simplify to 2 over 1. So there's a scale factor of 2 over 1 from the big to the smallest. Now we can do it again with the 8 to be 8 over 4. Again, it's going to be a scale factor of 2 to 1. And say for the 10 over 5, it's going to be a scale factor of 2 to 1. Again, this is from the biggest to the smallest. Now, if we do from the smallest to the biggest, we would flip it. So the other scale factor, depending on the question, you're going to get either from the biggest to the smallest to the biggest. We can do it backwards, which is 3 over 6, which is going to give us a half. So again, it's just the inverse. It just depends on the question they ask you. But the scale factor is the same nonetheless. It's just the inverse version if you go from big to small, from small to big. So here we have a scale factor. Guys, it's always in the simplified ratio. If you do not simplify it, it's never going to be the same. So please do simplify it all the way. So this scale factor is if 2 polygons are similar and the ratio of the corresponding sides of 2 similar polygons. So always reduce the ratio. But if you notice, all the sides are the same. So because all sides are the same, I can just go, I'm going to go from from small to big, so 6 over 3. It's going to simplify to 2 over 1. So our scale factor is 2. Now what does that mean? The scale factor is 2 if whether from the smallest to biggest we multiply by 2. And the scale factor will be 2 whether we go from the biggest to smallest because we divide by 2. Now right now we're working on just going from smallest to biggest. So it'd be from the smallest triangle to the biggest, it gets multiplied by 2. That's why the ratio is 2. So for example 1, they want us to find the scale factor A, B, C, D, M, N, O, P. They want us to find X, Y, and Z and then find the perimeter of each figure. I guess they ran out of words. And then find the ratio of the perimeters. Now, before we start, that seems like a lot of information, so let's break it down. Let's start with, it's going to be the same ratio for the perimeter as it is going to be the scale factor. So, scale factor equals ratio of perimeter. I'm just going to write prim because I ran out of space. Now, how do we find the ratios? The first thing you need to do is find the ratio of the figures. The only numbers we have are 10 and 8, so that's what we're going to use. If I'm going to do the small one on top, just because, but it's really not going to matter. 8 over 10, that's going to simplify to 4 over 5. You can also write it as 4 to 5 or 4 to 5. There's multiple ways to solve for this. But this is what we're going to use to find X and Y. That ratio of 4 to 5. So how do we do it? So X is right here, and it's in reference to that 4. So I'm just going to write the ratio 4 to 5, which we found. And realize the 4, it comes from the smaller figure. So that's where we're going to put the X. If it's on the smaller on the top, we keep the smaller on the top. Over the 4. Then we're going to go ahead and cross multiply. So we're going to get 16 equals 5x. And then we're going to get that x is equal to 16 over 5. Now, you can either leave it like this or convert it into a mixed number. I really, truly don't mind whichever you do. I'm just going to leave it as a mixed number, 16 over 5. Now, for y, we're going to do the same thing. We're going to do 4 over 5. 4 over 5 equals, again, y on the top because the 4 comes from the smaller one, over 12. We're going to multiply 12 times 4, which should give us 48, equals 5y. So then I divide and I'm going to get y is equal to 48 over 5. Again, I'm just going to leave it as a fraction. We're going to do the same thing for z. So 4 over 5 equals z over 14. So 14 times 4 is going to be 56 equals 5z. And then we get that z is equal to 56 over 5. Now, there we found the scale factor. Scale factor was 4 to 5. We found x, y, and z right here. X, y, and z. Now we can find that perimeter of each by adding them together. So the perimeter of the left is going to be 10 plus 12 plus 4 plus 14 is going to give us 40 units. And the slope and the perimeter for the other one is going to be 8 plus 16 over 5 plus 48 over 5 plus 56 over 5 is going to give us that the perimeter is 32. Now I need 32 units. I'm going to keep the perimeters in the squares. And again, the ratio of the perimeters is the same as the scale factor, so we found it as well, it being, again, 4 over 5. Now, for adding, it'll probably make it a lot easier if you guys made those fractions into mixed numbers. I just ran out of space, and I didn't want to run too much out. Like, I wanted to make sure everything was in the same slide. If you make it into mixed numbers, you should be able to add them a lot easier than if they are improper fractions. or if they're in decimal form. It's really up to you. If you like them in improper, keep it in improper. If you like them mixed, go ahead and mix them. If you like them in decimal, go ahead and do it. But that's how we found the scale factor 4 to 5. That's how we found x, y, and z. The perimeter, we added all of the sides. And then we found the ratio of the perimeter, which is the exact same as the scale factor. Even if we do 32 over 40 for up here, we're going to get 4 over 5 when we simplify. So it's going to be the same. So now we're talking about corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. Now, keyword right here, two corresponding lengths. Corresponding means they're going to be, well, corresponding, you guys know what that means? In a proportional manner. So in this case, we have an example 2 that's in the diagram. Triangle TPR is similar to triangle XPZ. And they want us to find the length of the altitude PS. Now, we know that we can get the scale factor from these two. And when we do that, that's how we're going to be able to solve for SP, which is this red line right here. Now, how do we get the scale factor? We're going to do, I'm just going to do the bigger one, XZ over TR. So it's going to be, I'm going to add the entire side, 8 plus 8 as 16. And 6 plus 6 as 12. Because again, it's not by half, it's the whole segment that's similar, guys. It's going to give us a factor of 4 to 3. This is our scale factor. Again, I'm going to just... And we're going to use that scale factor in order to solve for it. So we're going to do 4 over 3 equals... Now, since the 4 comes from XZ and XZ is from the bigger triangle on the right, we're going to put the 20 on top. And then we're going to put the X on the bottom, which is what we're trying to find, which is SP. Now, again, we're going to cross multiply 3 and the 20. That's going to give us 4x is equal to 60. I'm going to divide by 4 on both sides. That actually simplifies to x is equal to 15. Now, our x was or is SP. So we get that SP or PS is going to be 15 units, whatever the units are. So now we have theorem 8.1, the perimeters of similar polygons, which is if two polygons are similar, then the ratio of their perimeter is equal to the ratio of the corresponding side lengths. This is what we were talking about earlier, that the scale factor that we find based on the sides is going to be the same as the perimeter ratio. So it reduces to the same. That's the key word, the fact that it reduces. Oh my God. Reduces to the same length. Like we did in the previous example or a few slides ago, we had a scale ratio, like in example 1, of 4 to 5, if I'm not mistaken. And I think it was 32 to 40. And that's simplified to 4 over 5. So that's the example. This is just talking about what we already did, how it's simplified to the same thing. All right, for theorem 8.2, we have the area of similar polygons. That is, if two polygons are similar, then the ratio of the area is equal to the square of the ratio of their corresponding side lengths. Again, same thing. The ratio is going to simplify at the end to the same thing as we said before. So if we have KLMN is similar to PQRS, then the area of PQRS over the area of KLMN is going to be equal to the side PQ or the side KL square or the side QR to the side LM square, or the side RS is congruent to this over MN, or SP over NK square. So the area, you can just put that two sides over one over the other and you square them and you're going to get the same thing. All right, so for example 3, we have the diagram GHJK is similar to LM and P. and we want to find the area of LM and P. So we know, based on the last slide, that the area is going to be, we can say that the area is going to be Pn over Kj squared. They're telling us that's going to equal the area of LM and P over the area of GHJK. Now, we have right here the area of GHJK, so we're going to plug that in the bottom. We have KJ, and we have, so KJ is going to go here, PN is going to go right here. Now I'm going to open a new slide to work on this, so please keep in mind the numbers. So in this slide that I just opened, I'm going to write the same thing that we had before. I'm going to write it in highlighter. All right, so Pn over Kj, all of that squared, equals the area of LM and P over the area of GHJK. So we know Pn is going to be 21, and we know Kj is going to be 7. That's going to be squared, equals the area that we're looking for, which is LM and P, over the area that we have, which is 84, which is in the picture. Now, before you do anything else, I'm going to simplify the 21 over 7. It's going to simplify to 3 over 1 squared, equals, I'm going to change the area of LM and P to x over 84, just to make it a little easier. So we're going to end up with 9 over 1 equals x over 84. We're going to cross multiply 84 times 9. It's going to give us 756. So x equals 756 meters squared. Now, so the area of LM and P equals 756 meters squared. So we cross multiply the 9 and the 54 and the x and the 1. Just happens that x times 1 is just x, and that's how we got to x equals 756 a lot faster.